So here in this problem, we need to determine the angle in degrees through which a pendulum swings if its length is 50 centimeter and the tip of the pendulum describes an arc of length 10 centimeter. Let's try to understand it graphically first. So here we have a rigid surface. Now from the rigid surface, there hangs a pendulum, and this particular pendulum has a length of 50 centimeters. So that's given to us. So this length is 50 centimeter. Now let's say the pendulum is swinging. As it swings, this is the position, and one more position will be there, which will be to the left hand side. So that's this particular position. So as it swings, it is going to trace a path, a circular path. So it's given here that this arc has a length of 10 centimeter. This is given to us. Our goal will be to determine the angle which is subtended here, this particular angle theta. Now if we consider this to be a circle, a bigger circle, with this particular point to be the center of the circle, then we know that the angle subtended at the center of a circle is given by the arc length divided by the radius of a circle, of that particular circle. Now in our case, the arc length is 10 centimeter and the radius will be nothing but the length of the pendulum. So that's going to be 50 centimeter, and we get 1 over 5. And generally this theta is measured in terms of radians. So we have 1 over 5 radians. But clearly in a problem it's given here that we need the value in degrees. So that means we need to convert our values from radian to degrees. So here all we have to remember is the transformation formula, that pi radian corresponds to 180 degrees. That means 1 radian will be 180 over pi degree. So all we have to do is multiply 1 over 5. So this is in radians. If we multiply it with 180 divided by pi, then the resulting value is going to be in terms of degrees. Okay, fine. So here what we'll do, we'll consider pi to be approximately 22 over 7. So we have 1 over 5 times 180 divided by 22 times 7. So 7 goes to the numerator. So we have 5 times 36. So that's 180. Fine. Then we have 2 times 11 is 22 and 2 times 18 is 36. So we now have 11 times 7. 18 times 7 divided by 11. So this will be equals to, so this is going to be in degrees. So we have 7 times 8, so that's 56 with a 5 carryover. So 7 times 1 is 7, 7 plus 5, that will be 12. So we have 126 over 11. This is going to be the value of theta in degrees. However, we need to further simplify this. So let's work out with this. So we'll come to this portion. So theta came out to be 126 over 11 degree. Now if we write in the mixed format, we will have, so we have in 11, so 11 times 11, that's 121. We are left with the remainder of 5. So we have 11, 5 over 11 degrees. Okay, so here we have 11 degrees and also 5 over 11 degrees. We'll convert this 5 over 11 degrees to minutes. We have to remember the fact here that 1 degree corresponds to 60 minutes. So that means we will multiply 5 over 11 with 60 and the degree will get converted to minutes. Fine. Now, what's 5 over 11 times 60? So that means we have 5 times 60 over 11. So that's going to be 300 over 11. If we want to express this in mixed format, so this will be 27 3 over 11, which means that we have 11 degree, and 511 times 60 can be also expressed as 27 3 over 11 minutes, which means we have 11 degree, 27 minutes and 3 over 11 minutes. We can furthermore also convert 3 over 11 minutes to seconds. So here we have 1 minute corresponding to 60 seconds. So we have 3 over 11 minutes. So this will become 3 times 60 over 11. So this will get converted to seconds. So 3 times 60, that's 180. So we have 180 over 11 seconds. We can rewrite this in mixed format. So in mixed format, this will be 16 4 over 11. So this will be seconds. So that means we have 11 degrees, 27 minutes and 16 seconds. Here we can ignore 4 over 11 seconds. Fine. So that means this corresponds to option number D. So option number D is correct. We have 11 degrees, 27 minutes and 16 seconds.